Okay, hello everybody. Today we are going to continue with the computer system architecture. So, as I was explaining the last class about dual core design, we'll continue from the dual core design. Coming to the next topic, uh, we have uh, we have to see about dual core design in multiprocessors. So, when we come to multiprocessors, as I have said, we have two types: symmetric multiprocessor and asymmetric multiprocessor. So a symmetric multiprocessor is a processor which is used only for a specific task. It will have a master and master will control the slaves. So the this processor is used only for a special purposes. It will be used for a specific task only. Only for a special purposes. It will be used for a specific task only. Whereas in symmetric multiprocessor, this processor is used where the processors are connected in a peer way. There is no processor there is nothing like a master and slave relationship. So here when we come to the symmetric and asymmetric, the symmetric and asymmetric multiprocessor may be either different in terms of hardware or software also. So special of software or hardware can be used to differentiate these multiple processors. And among these multiple processors, as I have said, they can be used in memory accessing way. They can be differentiated in memory accessing, like uniform memory access and non-uniform memory access. So when we come to something like uniform memory access (UMA) is used to access the memory in uniformatical way. Like suppose if there is some available memory of 1 GB. So this available memory of 1 GB can be uniformly accessed by all the processors equally. Whereas in non-uniform, they can be ups and downs. Like one processor can occupy 500 MB, other processor can occupy only 200 MB, other processor can occupy 300, like this. There will be some non-uniform method. That is why they are called as uniform memory access or non-uniform memory access. So in this uniform or non-uniform, there is a recent trend in CPU design which includes converting cores. That is, these cores are nothing but we can call it as a chips. They can be a single chip or they can be a multiple chip. They can be a more than one chip which can be used in a multiple way on a single core. And this chips allows to communicate in a faster way between one chip to another chip. So as these chips are used, in addition, these chips are used with a multiple significant less power than multiple single core chips. Okay, so if you use a multiple chips, then it can be more effective and use less power. So as these chips are very useful, that is why we have the technology like multi-chip and multi-core chip. So multi-chip means in single in this one we'll be having multiple chips, whereas in multi-core we'll be having a single chip with multiple cores. There is a difference between multi-chip and multi-core chip. Okay, adding to the things you can see in the diagrams, the multi-cores. In a single processor, we are having, that is in a single chip, we are having multiple cores. You can see the diagram in a clear way here with the arrow graph pointing inside. These small things are what we call as cores. So here, coming exactly to the core. A core is a brain of a CPU. It receives the instruction and it is the main part which is used for doing the operations like calculation or taking the instructions or doing the task. A processor with two cores is what we call as dual core processor. A processor with four cores is quadra core. A processor with six cores is hexa core. Eight cores is octa core, as of. So it goes on like this. A CPU features between 2 cores and 12 cores, which is called as workstation, which is mainly used for the workstations. That is normal, this one are servers. And these cores are used for performance based. That is, these cores will mainly affect the performance of the computer. So if we come back to the history of this course, the Intel has developed the first core in January 5, 2006 with the name as Intel Pentium. The Intel Core is a computer processor which is used mainly for the laptops and desktops also. Then coming to the exact thing, how to monitor this course, how to go about this course, how to look for this course. We can look for this course by going to the task manager of a computer in Windows 10 or in any of the Windows. Just you will be having something called as task manager. From there we can see how this is going to, how many cores are there and how the system performance, everything we can monitor from the task manager. Yeah, now I'll try to show you how many cores are there in my system, in my desktop. How many cores are active? I'll try to show it. Just I'll show up the screen and I'll show you another one. Okay, as I've said, we need to go to the task manager. Task manager can be obtained by clicking on something like Control Alt Delete. So once we click on this task manager, just you can go to something like performance. In performance, you can see over here the the number of cores. Number of cores are two. That is, my processor is a dual core processor, and the how many processors are the logistic processors are four. Okay, suppose I want to see how many logistic processors working and how the performance of my system is done. Just I'll right click on the graph here. I can click on right graph and go to the logical processors. So you can see the logical processors are four and the four processors are continuously working. That is, inside two cores there are four processors. Okay, I'm having two cores, so a dual core processor. In that, I'm having four processors which are working continuously. So this is how we can monitor the performance of a system, like how many processors are there and how they are working. Then we'll come back to the 50 once again. Okay. Uh, this is our next one. Um, Fine. Next upcoming design is what we call as blade servers. Blade servers are nothing but all the input and output devices, everything are assembled in one chip, and they are assembled into a things which are in the form of blades. Okay, one after the other, they are assembled like this in the form of blades. Like if we come to this blade servers, it is something called as stripped down servers. Okay, which are multiple blades servers and multiple and all are provided with power, cooling, networking, various interconnection managements. And together, this blades and their complete system is what we call as blade systems. So these are the upcoming servers which are being used nowadays. So as I was saying that these are the servers are going to be maintained. That is, we can take this blade as one CPU. So if we take here altogether, we are having 6 to 7 CPUs, and all are connected together, interconnected. So these are the servers are maintained. Next, what we have is clustered multiprocessing operating systems. So here in cluster operating systems, it resembles parallel operating systems. As you can see here, we have computer 1, computer 2, computer 3, which are parallelly working and they will be sharing a common storage thing. So these clusters will have two or more computer systems which are merged, and primarily they will have only one common storage. These clusters can be differentiated based on the hardware or software. If they are differentiated based on hardware, then it can be called as cluster enable high performance disk sharing systems. On software, they are uh, differentiated, then this allow the systems to work together like this. So there will be a differentiation. If the computers are completely separated based on the hardware terminologies, then the performance might be more. This type of operating system can also be done based on the software also. So it depends on the way of you are going to use. So every computer is what we call as every node in fact. And these nodes of a cluster will be responsible for monitoring the operations of a computer. If any, suppose if there is any failure, then these clusters have to take care. The rest of the nodes, if one node is failed, the other nodes have to take control and has to work in cooperation. So there is how the cluster systems will be. So as I have said, these clusters are like multi-process systems, but they will have multiple systems working together. Uh, they usually share storage device, as I have said, and it will have high availability services. And basically, there will be two types of clusters: asymmetric clusters and symmetric clusters, which we'll be seeing in the later of the slides. And these clusters are used for high performance computers. Applications must be written to use parallelly, and some have distributed log managers to avoid conflict in operation. Like if two or more clusters are using the storage and there might be a conflict, so the log manager has to work over there by distributing the storage. So this is a symmetric cluster system where all the nodes are connected in the form of a sequential order. So here in this type of cluster systems, all the nodes run applications and monitor other nodes at the same time. So there is nothing like a master or slave. All the nodes are equally preferred and all the nodes will be able to manage each other equally. When we come to asymmetric cluster system, in asymmetric cluster system, we'll be having something called as odd standby mode. That is, so this node will take care of rest of other nodes. This node will be monitoring like a master and slave. That node will be monitoring the other nodes, whether they are performing in a perfect way or not. So the reserve asymmetric cluster system is going to be. Okay, that's it for this topic. Next class we'll start with the next topic. Until then, just we'll have queries. We'll try to take one or few queries depending on the things, and any doubts, anything can we can clarify with each.